Hi everyone, my name is Merasa Alizadeh from Osaka University. Welcome to this practice-oriented workshop session. Today I'd like to tell you about some of the VR apps that I have explored and experimented with, and together we will take a look at their affordances for teaching and learning a second language. So stay with me until the end of this presentation.
First, we will have a brief overview of collaborative learning and how it's conducted in face-to-face and online classes. Next, I'll introduce a couple of VR apps for collaborative language learning that I have experimented with, and then we will re-examine those apps in the light of the SAMR model. Finally, there will be a summary that wraps up this presentation. So let's begin with collaborative learning in second language education. Collaborative learning makes a huge part of every language learning classroom that emphasizes communication. For collaboration to occur in the classroom, learners are often assigned tasks that require them to mutually participate in a joint activity in order to accomplish a goal. However, despite all the benefits of collaborative learning, since the outbreak of the COVID-19 pandemic, teachers have been exploring new ways to transition existing face-to-face tasks and activities to remote online learning environments. One common practice is to use breakout rooms on Zoom or other video conferencing apps. In breakout rooms, students are able to use virtual whiteboards or share the screens if necessary. However, breakout rooms can be isolating and shy students may choose to keep their cameras and mics off, thus not contributing much to the collaborative task. We all know and have experienced how the level of engagement in general can be lower in virtual classes compared to face-to-face lessons. And the feelings of isolation and low engagement can be exacerbated by the fact that many students choose to keep their cameras off. While a lot of times there are good reasons why this happens, it's important to remember that a remote class session, especially if it's a lecture type of class, can seem like one long educational video to students. Another challenge commonly faced by the users of video conferencing tools is what has come to be called Zoom fatigue. In this article by a Stanford professor, we learn why video conferencing can cause fatigue, the so-called Zoom fatigue, which not only refers to Zoom but also to any other video conferencing tool. Just like Googling is used interchangeably with any web search, the term Zooming has become ubiquitous and a generic way to replace video conferencing. Popular video chat platforms have design flaws that actually exhaust the human mind and body. The first reason is the excessive amounts of close-up eye contact that's highly intense. Second, the cognitive load is much higher in video chats. And third, seeing yourself during video chats constantly in real time is tiring. Last but not least, video conferencing dramatically reduces our usual mobility. One potential solution to part of this problem can be to integrate immersive reality into learning experiences. In this workshop, we will focus on virtual reality or VR, but before we get into the details, there are a few caveats to be aware of. Number one, immersive learning is not a substitute, but rather a supplement to other tech tools such as Zoom. Number two, there are not yet as many apps dedicated to language learning as there are apps for, say, entertainment. Therefore, the apps you may come across mostly require a substantial amount of creativity and task design on the part of teachers to make them most effective for immersive learning. And last, despite the scarcity of language learning VR apps, there are a number of social VR apps that appear to be promising platforms for use in educational settings. With these points in mind, let's go over the 4 apps you see here, beginning with Spatial, then moving on to Engage, and next to Mozilla Hubs, and finally Frame VR. Spatial, available at spatial.io, is a cross-platform app that provides virtual spaces for users to get together. Spatial can be joined from any device in 2 modes of virtual reality and augmented reality. Today, we'll take a look at the web version of this app. All right, here we are in a room that I have created for the sake of this presentation. In a spatial room, just like in a Zoom room, you have the capability of sharing audio and video. But you may also have an avatar, as you see here, which can move around with the WASD keys. W to move forward, S to move backward, D and A to move to right and left. You can also click a spot in the environment to immediately move your avatar there. Screen sharing is also possible when using the web app. In addition, a range of different file formats such as PDFs, images, Microsoft Office files, web pages, and 3D models can be shared in a spatial room. Like the rest of the apps that I will introduce today, Spatial has the feature of 3D audio, meaning that you can hear other people more clearly as long as your avatar is close to theirs. But as you move away from them, you start not being able to hear them as clearly. Pretty much like what happens when people break into groups in a real-world environment. There are a few default environments to choose from, which you can see here. Right now, we are at an outdoor venue that looks like a campfire, but it's possible for the host to change the environment and move all users to a different virtual location. Let's try moving to the mountain lounge. We are now back to the same room where we started. Spatial is a proprietary app with a freemium version that allows for rooms of up to 32 people. I have tried the web, mobile, and Oculus Quest 2 apps, and they all work in a stable manner. I have used Engage in 2 projects. The first one was to create on-demand video content for Japanese learners of Russian. My colleagues and I wore Oculus Quest 2 headsets and got together in Engage rooms to record learning materials. Sometimes we'd gather in a classroom like this, and other times in an outdoor venue like the sand beach you see here. In another project in collaboration with Okayama University, we followed a self-directed learning pedagogy in which a small group of students and 2 teachers, including myself, met regularly and engaged, and every time the students reported on the apps that they had explored on their own and how they thought those VR apps could be used for educational purposes. This was the first step in using Engage with a group of students, and we tried to keep the number low so we could make sure that the environment is safe and it's not affecting students in a classroom context. Therefore, we opted for an informal learning setting and we gave the students a free hand in exploring their own VR apps. We found that although Engage is a very high-end app, it has its own limitations and more features come with a paid account at a high expense. So the first 2 apps that we looked at are proprietary apps that offer freemium accounts.
However, the next two apps that we want to get to follow open standards of VR, meaning that they're free to use and the space in virtual reality that they provide, the links last forever. And what's even better than all of these is that they're both browser based. So, whatever device with a browser you have, you can access these environments created with Mozilla Hubs, which we're first going to look at, and then Frame VR or Virbela Frame, as some people call it. Okay, so Hubs is available at hubs.mozilla.com, and it's an open source program. And you can easily create a room here. And if you click join room, I give mic permission and I enter the room. The default room or virtual space that you usually first get to looks something like this. And again, like the other apps that we just looked at, W, A, S, and D keys work for moving around. Again, a lot of other features that we saw in the rest of the apps are available here. For instance, you can chat with others here. One interesting thing about Mozilla Hubs is that if you put a message in the chat and if you use this magic wand, it creates an object of it for you and it adds it to that environment. And then you're free to move that object around or stick it to a wall or just if you don't like it, delete it. You can place various types of items here. You can use the digital pen, you can share your camera or a GIF file or any of the 3D models that a lot of people usually bring in from Sketchfab or some of the ones that are featured by Hubs itself. If you're on a desktop, you can share your screen. Voice can be turned on and off. And then if you host a Hubs room, you can send an invite link or code to others to join, or you could even embed that in your website. Let's move around a little bit and see what this space looks like. Here we go up the stairs to the second floor. As you can see, by clicking the mouse, I can turn around and navigate to right and left. Here we go. There's also the fly option in this app that can be activated, and it gives you a bird's eye view of the environment you're in. So simply by pressing G, you can activate flight mode. And if you look up and press the W key, right now I'm going to bump into the ceiling, you see me going up. And if I use the mouse to look down, you can see this space from the top. Yeah, this is what it looks like. And by pressing G again, flight mode is disabled, so I'm back to where I was. One of the other features of Mozilla Hubs, like a lot of other VR apps, is spatial audio or 3D audio, which we already talked about. This makes it a great app, a great environment or platform for students to do collaborative activities. If they want to break into groups, this is a much more natural way of doing it. And then there are avatars to share with people. So there's a lower level of inhibition that a lot of our language learners usually suffer from when facing somebody and speaking to them. You can, again, bring in a lot of objects, change the room settings. There's a lot of details that go into this, and I think that's beyond the scope of this primer. But hopefully, if you're interested, I can share another video that I did on this at another event, and that gives you more details about it. So this brings us to the end of this part of the presentation about Mozilla Hubs. Hope you'll explore it on your own and enjoy using it. Last but not least, we get to Frame VR by Virbela, which when you enter the link framevr.io looks something like this. It's a VR lobby, a VR room that has got information all around about how to get started. Like Mozilla Hubs, Frame is also browser-based, and it's available on PCs, mobile devices, and headsets alike. There are many similarities between these platforms and a few differences, but basically they work in the same way, and many of the same features are available in Frame just as they are in Hubs. Once you create a room, again, you are given a link and you can keep that forever, or you can just customize that link, or you can bring in many objects. You see a lot of different settings in this menu. Your inventory, the frames that you've created, and there are many how-to files or pieces of information that you can find around about navigating the environment and gathering users or creating frames and sharing them. So yeah, this has got many great affordances for collaborative learning again. Spatial audio, as I mentioned previously, is available in Frame 2. And a lot of these tasks that require students to explore and navigate an environment like scavenger hunts or to create stuff within VR can be easily done with Frame as well as Mozilla Hubs. Okay, so I won't get into any further details, but generally speaking, these platforms work well with collaborative language learning tasks. So I hope you can take the chance to explore these two platforms with your students, as they're both free and they work with browsers very well.
Now that we have learned about 4 immersive learning, in particular VR apps, let's take a look at the SAMR model, which is a well-known technology integration model, and later on re-examine those apps in the light of this model. SAMR, which stands for Substitution, Augmentation, Modification, and Redefinition, is a technology integration model proposed by Dr. Ruben Pentadora. This model can be used to determine whether the technology integration is enhancing or transforming the learning experience. Take the example of a paper and pencil storytelling or creative writing task. Now let's see how the task can be integrated with technology along the 4 levels of the SAMR model. At the lowest level, that is substitution, you type the written text instead of handwriting it. This creates a digital copy of the same piece of writing, but nothing beyond substituting a handwritten text with a typed text. Now, if your word processor has spelling and grammar check functions, then you have gone one step further by augmenting the writing task with technology. The first 2 levels of technology integration model, that is substitution and augmentation, allow only for learning enhancement. They're necessary, but in most cases insufficient. The goal of educators should be to move to the upper rungs of the ladder and to transform the learning experience with technology. Going back to the example of the writing task, a collaborative word processor such as Google Docs can make it possible for learners to share their work with others and give and receive feedback. Finally, having learners create videos and multimedia content based on a storyboard they have created from their writing makes it impossible to implement the task without technology, thus redefining it substantially. Here are my final remarks before getting to the summary. In general, virtual reality, if used effectively, does allow for tasks that would otherwise be impossible without the tech. This means that when incorporating VR into our curricula, we should ideally aim for transforming the learning experience. We saw earlier that social VR apps can help us transform collaborative language learning by providing a private space to learners in which they can break into groups more naturally, communicate using various media, access the apps on different devices, and use avatars that potentially lower their effective filter. Accessibility issues play an important part. As a teacher, you should make sure that the VR app you adopt matches your students' hardware, does not cause any major physical discomfort to them, and that they all know how to use it. As previously mentioned, there are not as many language learning apps out there. It's therefore our responsibility as educators to explore various options and come up with tasks that can be accomplished using existing apps. It's here that some creativity in task design, or in other words, modifying or redefining the task, comes into play. It's time for a summary to wrap up this presentation. In today's workshop, we learned about 4 VR apps: Spatial, Engage, Mozilla Hubs, and Verbella Frame. And we also had a look at their affordances and limitations for use in language learning classes. Later on, we had a look at the SAMR model and re-examined those apps in the light of this technology integration model. I hope that this presentation has helped you find out a little more about immersive learning and web VR in particular, and that it has piqued your interest to try this out with your students in your own classes. Feel free to contact me using this email address or otherwise find me on Twitter with this handle. Thanks for watching.